Hello everyone, welcome back to another series of tech demos. In today's journey, we are delving into NSX VRF-Lite with the focus of inter-VRF routing and route leaking. Before we dive in, make sure you have checked out my previous video series on NSX-T deployment from scratch in my home lab. It's a crucial prerequisite for this lab. If you are new here or missed those videos, I would highly encourage you to give them a watch first. The link is in the right top corner. If you're enjoying our content and want to stay updated as we journey towards becoming NSX experts, so don't forget to hit the like button, subscribe and ring the notification bell. So let's get started. So about the VRF-Lite, virtual routing and forwarding allow the coexistence of multiple routing instances in one routing device. Independent routing and forwarding tables are maintained for each instance. Separation between tenants and applications does not require additional Tier 0 gateway and NSX edge node with the VRF-Lite. VRF-Lite provides logical routing isolation in NSX and spans it to the external peer device that support this technology. So moving to the next slide, we have VRF-Lite requirements and limitation. A Tier 0 gateway must be used to deploy VRF gateways. It is a default Tier 0 gateway and it is the parent gateway for the VRF gateways. Default Tier 0 gateway can be existing Tier 0 gateway which is connected to Tier 1 gateways. Moving to the next slide, this is the VRF-Lite topologies. VRF-Lite can be deployed in single tier and multi-tier topologies. VRF gateway can only be deployed as Tier 0 gateways. A trunk is used to interconnect the different VRFs with the physical gateway. The physical gateway and the underlying infrastructure like vSphere distributed port group have a support trunking. Tenant can be connected to the Tier 0 segments and Tier 1 segments. So if you look at this example, we have Tier 0 connected directly to the Tenant 1, Tenant 2, and on the right we can see Tier 0 connected to the Tier 1 first and Tier 1 further connected to their VMs and their applications. And if you look at the Tenant 2 further connected to the Tier 1 first and Tier 1 is connected to the Tier 0. So this is a VRF, you can say VRF1, this is the 1 and this is the VRF2. Further it's using the parent VRF to connect towards the data center or moving out. So moving to the next slide, these are some use cases for VRF-Lite. On the left, we can see the only solution for the customer that requires separate network routing instance for each tenant is to deploy multiple Tier 0 gateways. However, the deployment can create scalability issue because only a single Tier 0 gateway can be deployed per NSX edge node, specifically for the deployment based on the bare metal edges. On the right, VRF-Lite helps network administrator to deal with the overlapping of network ranges in same routing domain between business unit or after a merger. Also in this diagram, we can see the green area, the green circle, and this is a Tier 0 which is a parent, and the further the yellow VRF, the red VRF and blue VRF, these three are the child VRF which is further connected to the Tier 0 gateway, and this is the parent or default Tier 0, and these are further connected to their VRFs as well. Forward, these are the VRF-Lite gateway interfaces. The very first here is a LR trunk port that is connected to the physical router or physical switch or L3 switch toward the Tier 0. The second is the uplink. Uplink is internally connected to the LR port and then it's connected to the VRF. If we have n number of VRFs, we have that link which is connected to the LR trunk port. The third link, so intra-tier transit link is something which is linked between both the SR and DR of the specific VRF. If there is a VRF1, VRF2 or N, so they are going to be create another link for each and every. And then there is a downlink. Downlink is something where the VMs is going to be connect. And in last we have a router link. The router link, under the router link, the DR is further connected to the SR of the Tier 1. So this is something, if we have a Tier 0, Tier 1 topology, in that case Tier 1 is connected to the tier 0 using the router. So jumping to the last slide, before start demonstration, how we need to configure and what all the things would be required to configure VRF. This is the control and data plane of VRF. So in the VRF, a dedicated BGP instance run in every VRF. You don't need to use the extension in the MP-BGP protocol to exchange the VRF routing information. BGP is the control plane because it's dynamically propagate and update routing information to all VRF peers. Each VLAN map with the VRF and only transfer the traffic for the VRF. So if you look at this diagram, you can see on the left we have NSX environment where the NSX, each VRF BGP is linked toward the VLAN per VRF. For example, this is a, you can say VRF red, this is a VRF orange, or this is a VRF purple. These are further linked with the different VLANs. So for example, this is a VLAN 1, VLAN 2, VLAN 3, or VLAN 3. And these are further connected to their data center. This is how that picture looks like. So we are done with the theory part here, and now time to start demonstration the VRF, how we need to configure the VRF and all route leaking and routing, inter VRF routing, which we used to call. And let's start with the demo, and probably in the next video I'll start with the demonstration of the things. So let's wrap up this one and stay tuned. Thank you.